Imagine a world of eternal night, thousands of meters below the sunlit surface where the ocean's crushing weight and icy darkness seem utterly inhospitable. Yet here in the abyss, nature stages one of its most astonishing spectacles, hydrothermal vents. Towering mineral chimneys rise from the seafloor, spewing superheated, chemical-rich plumes into the freezing water. This is not smoke, but a blistering soup of minerals erupting from the planet's core. Around these vents, life flourishes in spectacular abundance, thriving against all odds. The water erupting from the vents can reach over 400 degrees Celsius, while just meters away it's near freezing. Creatures here endure crushing pressure and wild temperature swings. For centuries, we believed all life depended on sunlight and photosynthesis. But in 1977, the discovery of these vent communities shattered that idea. Here, life is powered not by sunlight, but by the chemical energy of the Earth itself. This revelation opened our eyes to the possibility of life in places we never imagined. In the deep sea's darkness, a new world was revealed. The birth of a hydrothermal vent begins with the restless seafloor, fractured by shifting tectonic plates. Cold seawater seeps deep into these cracks, journeying towards magma chambers far below. Heated by the Earth's interior, the water becomes a superheated, mineral-rich fluid. Under immense pressure, it stays liquid, reacting with rocks and absorbing metals like iron, zinc, and copper. This hot, buoyant fluid surges back up, bursting through the crust in a dramatic underwater geyser. When it meets the frigid seawater, minerals instantly solidify, forming the iconic plumes and chimneys. Over time, these minerals build up, creating towering structures. Black smokers spew dark, iron-rich plumes, white smokers release lighter minerals. Each vent becomes the foundation for a unique, isolated city of life. In the deep sea's desert, these oases are born from fire and water. In the deep ocean, sunlight never penetrates, so life found another way. Here, microbes use chemosynthesis, turning toxic chemicals from the vents into energy. These bacteria and archaea harness hydrogen sulfide, oxygen, and carbon dioxide to produce sugar, fueling the entire ecosystem. Microbes form thick mats on rocks and drift in the water, feeding shrimp, crabs, and filter feeders. But the most remarkable adaptation is partnership. Many vent animals host these bacteria inside their bodies. The animal delivers raw materials. The bacteria provide nutrients, sustaining their hosts from within. This symbiosis allows animals to grow large and thrive in dense populations. Without ever eating in the usual sense, it's a perfect collaboration, a biological contract forged in darkness. Chemosynthesis is the engine of these deep-sea oases. Life here is built on chemistry, not sunlight. Around hydrothermal vents, life takes extraordinary forms. Giant tube worms, up to 2 meters long, cluster in dense thickets, mouthless, gutless, nourished entirely by symbiotic bacteria. The Yeti crab waves its hairy claws in vent fluid, farming bacteria on its bristles for food. The scaly-foot snail, armored in iron sulfide, survives in the hottest, most toxic zones, nature's own night of the deep. Blind white crabs, heat-sensing shrimp, and bizarre fish all thrive here, each uniquely adapted to the extremes. Every species has evolved tools to survive crushing pressure, wild temperature swings, and toxic chemistry. These creatures prove that wherever there's energy, life finds a way. The vent communities are a testament to evolution's ingenuity. In the deep, life is stranger and more resilient than we ever imagined. The abyss is alive with wonders. Hydrothermal vents may hold clues to life's origins. Some scientists believe life began not in sunlight, but in the dark, energy-rich environment of deep-sea vents. The microbes here resemble Earth's earliest life forms, offering a glimpse into our planet's ancient past. If life can thrive without sunlight, perhaps it exists elsewhere, on icy moons like Europa or Enceladus, where hidden oceans may shelter similar vents. Studying these ecosystems has practical benefits too. Enzymes from vent microbes power DNA research and may help create new medicines and biofuels. Yet we've explored less than 1% of the deep ocean. Each new vent reveals unique species and scientific wonders. The deep sea remains a frontier, essential for understanding life on Earth and beyond. In the darkness, discovery awaits.